Hey Math 1, I'm back. So, this is part 2 of our order of operations proofwriting lesson. And I know what you're thinking. You might be thinking like, what are we doing with these proofs? And the idea is I'm just trying to get you guys kind of like introducing you to the idea of proofwriting through algebra. And I can pretty much guarantee that you'll see it in Math 2. So not only is this going to help you learn how to document steps better, but it's going to do better things for you moving on like to Math 2. So here's what a full example looks like. This is what I'm expecting on every single problem. Okay? So we've got our example. The first move that I always want you guys to make is to rewrite the left-hand side and say it's the given. All right, so that's always our first move every single time. So that's our given. Now, how are the order of ops going to move through that? Well, you're looking inside the brackets. There's a whole bunch of stuff going on. I got 3 divided by 15. I see parentheses here. I see more parentheses. I see more parentheses here. And I think a very good idea, and we talked about that when we were doing the geometry stuff, is when you see parentheses that are doing nothing but acting as placeholders for multiplication, like it's just saying, hey, take 15 times 5, take 5 times 6. When you see that, it might be to your benefit to just say, these just mean multiply. These just mean multiply. These just mean multiply. I think you'll run into fewer issues along the way. So there's no exponents. So parentheses, that's what this is. Exponents, we have none. Multiply or divide left to right, that's the next step in the order of operations. I see division right here. So here's what we're going to do. We are going to rewrite this division statement in terms of a fraction. So I say we figure it out over there because you're documenting every single step, right? You're going to say 3 divided by 15. I'm going to rewrite that as 3 over 15. And then I'm going to reduce that as a fraction. So the top and bottom both divide 3. So you take 3 divided by 3. 15 divided by 3, which gives you 1/5. So that's going to be our first move. We are now rewriting everything inside the brackets exactly the same, except 3 divided by 15 is now 1/5. Times 5 times 6 minus 3 times 2. And the property for that, if you'll go and look up at the note sheet, all right, if you check out that property list is very clear that if you take division and turn it into a fraction and reduce it, that you are under the umbrella of the substitution property. Okay, so that's the justifying step for our first statement. Sub. So you can just put sub for substitution property. All right. So now, since we're writing this as a proof, we're trying to not skip a bunch of steps. Skipping steps in a proof is sort of like the death knell. It's like you're not going to get full credit for that because you're not proving it. So when you see multiply or divide left to right, you can take 1/5 times 5 and check that out. So 1/5 times 5 looks very similar to one of the first moves we made on that first proof we did. And it ends up just being 1, right? It's 1/5 times 5 over 1. The 5's cross cancel. It's 1. Now think to yourself, do you remember what property that is? Let's check out the steps. It's not substitution because these are kind of like the throwaway steps. It's not additive identity because you're not adding 0. It's not additive inverse because we're not getting 0 through a calculation. We're not even adding or subtracting, so it's not additive inverse. It's not the multiplicative property of 0 because we're not multiplying and getting 0. It's not the multiplicative identity because the multiplicative identity says multiply by 1, get itself. Multiply by 1, get itself. Multiply by 1, get itself. Multiply didn't multiply by 1, and you didn't get yourself. So it ends up being the very first step. Sorry, I'm saying steps, I mean properties. That makes way more sense. I'm multiplying by the fraction flips of my original statement and getting 1. I'm multiplying by the reciprocal, I'm multiplying by the inverse, and I get 1 at the end. So, multiplicative inverse would be that move. Whoa, okay. So I didn't even finish this, right? It's like, okay, doing the multiplicative inverse, this became 1 times 6. Now here's an interesting thing. If it's separated by addition or subtraction, you can do that step at the same time that you do a multiplication problem in a different one. So, you know what? I'm going to say an offshoot of that step is that 3 times 2 is 6. And if you check out your list of things, this isn't a special move. It's sort of just like saying, I'm multiplying two numbers. There's no inverses involved. I'm not adding and getting 0, and I'm not multiplying by 0 or the identity. This is just a substitution property. Yeah. So you can do multiple steps on the same line. You just got to make sure they don't conflict in the order of operations. All right, next move, I'm just looking at this and I know 1 times 6 is 6. And I know 6 minus 6 is 0, but I'm not working ahead. So the question is, what did you do to get from here to here? I took 1 times 6, and I got 6. Check out the sheet of properties. It seems like we're multiplying by 1. Not the multiplicative inverse, because those aren't multiplying by 1, they're getting 1. It's the multiplicative identity. 3 times 1 is 3. 3 1/3 times 1 is 3 1/3. -7 times 1 is -7. Multiplicative identity for that one. Sorry, I know the scrolling is irritating. I just need to get more high tech. I will at some point. I'll figure it out. All right, at this point, it's kind of like you're getting very close to the end. 6 minus 6 inside the parentheses is 0, and I can just sort of like relinquish, or not relinquish. I can just sort of say the brackets are gone, right? Addition to brackets, there's no need to keep the 0 inside there. All right, so what did we do? We said 6 minus 6 is equal to 0. That's the additive inverse, when you add or subtract and you get 0. So I say 6 minus 6 equals 0 here. Additive inverse. And then the last move, indeed, we get 7. That's the end of my proof. But I do make sure you document the very last step here. 7 plus 0 equals 7. Now, if you look at the first page of notes, anytime you add 0 is the additive identity. All right? So check out the 5th property. Right here. 3 plus 0 is 3. 0 minus 4 is negative 4. Negative 2 plus 0 is negative 2. This is the additive identity when you add 0 to something and it just becomes the same thing at the end. All right. Thank you so much for your patience on this. This is particularly this lesson requires a lot of students because you have to say to yourself, all right, I'm doing this thing called writing proofs, and maybe I'm not seeing exactly where it's going to come into play later, but you just got to trust me on this, that the documenting of each step is for this process. Basically, just trust me, okay? All right. On this next video, what I'm going to do is 2 examples where I'm not scrolling up and down. I'm just trusting you guys to say, you're looking at the list as I'm explaining things, and you're following along as I do the proof. So 2 more proofs in the 3rd video, and I think you guys will have a pretty good set of resources to at least attack this better than just an in-class explanation.